Hey, what's up everybody? My name is Moss, and in this video, I'm going to introduce you to OpenTelemetry Weaver. To start, I'll do a brief introduction of Weaver, and then we'll jump into a short demo. There are several common problems that are encountered by SRE teams, platform teams, and development teams. Deployments of new software break alerts and dashboards in the team's observability backend because metric names were changed, updated, or even deleted. And oftentimes they have to use complex queries in their observability backend because teams use different names for the same thing. And this can result in an unnecessary amount of hours being spent debugging an issue due to missing or unclear instrumentation. So what we're really talking about here are semantic conventions. Semantic conventions are standardized names, types, and formats for your telemetry data. They're essentially a contract that says, this is what our metrics should be called, and these are the attributes they should have. OTel Weaver helps organizations implement observability by design. It's an open source CLI tool that helps you manage, validate, and evolve OTel semantic conventions. With OTel Weaver, you can define and version your own semantic conventions and enforce naming, stability, and best practices. The CLI tool also provides a command called live check, which allows you to verify that your application emits what your schema defines. And Weaver can auto-generate docs and code based off of your schema. It can track diffs between versions of your schema and detect breaking changes. With that, let's see a quick demo of OTel Weaver in action. Imagine a scenario where you deploy a new version of your service, but someone accidentally misspells a metric name. Without validation, you might not notice until a customer-facing outage occurs, and suddenly your dashboards are missing the data you need to troubleshoot the issue. With Weaver, you can integrate checks into your CI/CD pipeline to make sure that the metrics you need are actually there and in the correct format. Okay, so what's going to happen is we will start the Weaver application using the live check option, and Weaver will listen on port 4317 for OTLP data, and then we'll start our application. Our application will be listening on the order endpoint, and then I'll run a load generation script that will create traffic against our application. Our application should emit telemetry data and send it to Weaver. Weaver will then receive that telemetry data and validate it against this semantic convention schema in the registry that we've defined here. Once Weaver is validated what is included or emitted by our application, then it will produce a coverage report and specify any violations that were found during the live check. Rather than running this start Weaver script, it's basically just a single command. I'm going to invoke Weaver directly from the command line. In this Weaver command, we're running the registry command with live check, and then we're also specifying where the registry is located here in the model directory. So at the beginning of the registry live check, it just validates that it found the registry manifest, which is just a very small file where we define the registry name, which is order service, and we say that this is the semantic conventions for the order service demo. And it confirms that it has successfully loaded the semantic conventions. The live check process stops when there is 10 seconds of inactivity, which can be adjusted when you run the command, but I will go ahead and run it again. And then I'm going to open my second terminal, and I'm going to start our Go application. And then I'm going to run our load generation script, which will start sending orders to our application. And you can see here, we are sending a total of 10 orders. So I'm going to go ahead and stop the application. And then you can see that there's output in the first terminal that's running the Weaver live check, and then it should automatically stop the live check after 10 seconds of inactivity. Okay, so Weaver completed the live check, and it took about 40 seconds. And we get this summary at the bottom of the report. So it says registry coverage, entities seen 100%. So that's good. We have 100% coverage, meaning our application emitted all of the metrics that were defined in our registry schema. Then if I scroll up here, we can see the total number of samples taken, which is 178. It specifies attributes, data points, metrics, resources seen, and then we also get this report by highest advice level. No advice, there was 162 samples that had no advice, but then we had 16 violations. And so under the advisories given, we can analyze those violations, which is a total of 16, and it says missing attribute. And then the advice message says attribute service name and service version does not exist in the registry. Now I want to call out that you can use your own custom registry and the standard OTel semantic convention registry as a dependency so that you can get all of the standard semantic conventions as well as your custom semantic conventions. And in those cases where you add the standard OTel semantic convention registry to your, in this case, you would add it to your registry manifest file, then these would not be violations. And if I scroll up, we can see the individual metric data points that were sent and processed by OpenTelemetry Weaver. Now, what happens if we were to change our application code and let's say we accidentally misspelled a metric name? What happens when we run the Weaver live check? I'll open up the application code. And here on line 83, where we define the order processing duration metric name, I'll just misspell it and remove some letters there. So what we should get is less coverage when we run the Weaver live check. So I'm going to rerun Weaver and do the load generation again. So after running Weaver again with the misspelled metric being emitted by our application, you can see that the registry cover drops to 75%. And then in the advisories, under the advice message, we can see metric does not exist in the registry. And what it's referencing is this misspelled metric name. So this is really powerful because you can run this coverage report as a part of your CI/CD pipeline so that every pull request gets validated. And you can catch telemetry issues in code review rather than during an incident. Now, I'm not sure why in this default report format, it doesn't specify what metric within the schema, defined within the schema, was not seen. But there is a way to actually see, okay, well, what was the metric that was not covered by our application? And if we rerun the Weaver live check, but with format JSON, then we actually get some additional information that specifies what metric was not covered. So I'm going to run that real quickly. Now, when we run with the output formatted as JSON, we get this additional data in the report, which gives us seen non-registry attributes, seen non-registry metrics, as well as seen registry attributes and seen registry metrics. And this is how we're able to identify why the coverage was lower. Under seen registry metrics, it gives us the count of how many times that metric was seen. And you can see here under order processing duration, this metric was seen 0 times during the live check. And that's why our coverage was 75%. Now that we've performed several runs of the OpenTelemetry Weaver CLI, I'd like to dive deeper into the implementation details of this repository. Let's take a look at the code in the application, which is a very simple web service with a single endpoint that simulates placing an order. At the beginning of the main function, we define the OTel endpoint that this application should send telemetry data to, and that endpoint is actually OpenTelemetry Weaver. So OpenTelemetry Weaver will be listening on this port for telemetry data from our application. Here we're creating a resource and utilizing the semantic convention service name and service version. And what I want to point out here is that these are defined standard OTel semantic conventions. Service name and service version exist. But because we're using a custom semantic convention registry where service name and service version were not defined in that registry, the OpenTelemetry Weaver runs failed validation on service name and service version. Down here, we define a new order service meter, and then we define our metrics. So the first metric here is order processing duration. And down on line 91, we define a second metric for order count. On line 101, we're registering a handler function for the order endpoint, and that we'll call handle order, and that's defined further down here. Okay, so in the handle order function, we've received a request to the order endpoint, and we parse that request. If the request status is empty or the payment method is empty, then we assign a random string for the order status as well as the payment method. We simulate a random duration for the order processing time, and then we record that using the processing duration metric that we previously defined. And then we're also appending an order status attribute and an order payment method attribute based off of the values that we received in the request. And then finally, we're incrementing that order count metric. Now with OpenTelemetry Weaver, we create a custom registry of semantic conventions by defining a file that will define all of the metrics and attributes for those metrics that we expect to see emitted from our application. So in my case, I've defined that registry within this file here, the semantic convention YAML file. And the first metric that's defined in this registry is metric order duration. And if you look at line 8 with the metric name, it says order.processing.duration. And this is an important part of the definition because this metric name must match what is emitted from the application. Additionally, you'll notice here that the unit is also specified as seconds, which is what we defined in our application. So we did define an order processing duration metric with a unit of seconds. We specified the stability of the metric as stable, and then we're also associating attributes with this metric as well, which include order status and order payment method. And we can set requirement levels for each of those attributes on whether or not Weaver will fail its coverage test or not based off of the value of the requirement level. And then the second metric that we're defining is the order count. And again, the metric name is important. It matches the name that we've defined in our application code. It's a counter and it's stable. And then we also define what attributes are required or associated with that metric, which in this case is order status. Here we're only defining the metric, but we have to also define the attributes themselves. And starting on line 34 is where we define a group of attributes that are common attributes for orders. So the first attribute is order status, and we can specify what are the expected values or allowed values of the order status attribute. And in this case, we've defined pending, confirmed, shipped, and canceled. On line 61, we define the payment method attribute, which you'll notice here we do allow custom values for this attribute, but we also include expected values here, which are credit card, PayPal, and bank transfer. So in this video, we defined a semantic convention schema, ran an application that emitted telemetry data, and then used Weaver's live check functionality to validate it in real time. Weaver helps you build observability into your development process from the start, so you can stop worrying about broken dashboards and missing metrics. I hope you enjoyed this video, and if you did, we'd love to hear your feedback. And if you're interested in trying Splunk Observability Cloud yourself, you can navigate to this link to claim your free 14-day trial. Thanks for watching.